negative square. It's positive, right? What about on negative 1? Let me go back to negative 1. It was negative 2 times negative 1. Then we knew that was a negative all over. Negative 1 squared is 1. Take away 9, so that's negative on the bottom. Shouldn't the top have been positive? Is that what we said it was? Positive. No, it's negative. Yeah, put in your... That's really the point here, is that we can sit here and go through this and try and do it quickly, but at the end of the day, you just have to plug numbers into a function, right? And take your time through it and get it right. Let me just do something real quick. I know that's negative, negative, that's positive. I know that's x plus 3, x minus 3. So if I plug in negative 1, I get negative. So that's positive. If I plug in 1, I get 1. So 1 should be negative, right? This one should be negative? And plug in 4. 4. Positive. You need to practice plugging those in yourself, okay? So what does this tell us? Where's our function concave down? Did anybody get something different than that? Because I really went quick through that. I'm not really paying too much attention. Anyone try it? Get something different? No? Where are we concave down? Negative infinity to negative 3, union 0 to 3, right? That's what I'm talking about here. Where are we concave up? Negative 3 to 0, union 3 to infinity. How about inflection points? What do y'all think about inflection points? Only 0. Only 0. Why not negative 3 and 3? They're not in your domain. Those are your asymptotes. So only 0 gives you an inflection point. And then we'd say 0, and then you have to plug that into the original function. What do you get if you plug 0 into the original function? You get 0. So the origin is an inflection point. All right. We have done steps 1 through 7. Now it's time to do step 8. Make a table. So look, if this is your page, I would start maybe a new page, all right? Oh, shit. Okay, if this is your page, starting in the first half, we're going to do the top half is going to be a table, and then the bottom half is going to be a drawing, okay? So everyone make sure you have a full page to work with here. Okay, what I'd like for you to do now, this is make the table. And the way the table is going to work is as follows. Just draw a number line. I want you to put first on this number line all of the places where your first derivative was 0 and all the places where your first derivative was undefined. So where was our first derivative 0? No, that's where it was undefined, right? There was no solution for where it was 0, so I'm not going to put anything. But where was it undefined? At negative 3 and 3, okay? So everything I got from the first derivative I'm going to put here. Negative 3, positive 3. Now, go to your second derivative. Where was your second derivative 0, and where was it undefined? 0, right? And 3 and negative 3, right? Okay, so all you do to start this is draw out basically the critical numbers for both the first and second derivatives. Bless you. Now, above this, I'd like you to draw 1, 2, 3 lines, and then we're making a table here, like this. And then dotted lines coming straight up from those critical numbers, like this. Then on the left side of your table, I want you to write F prime, F double prime, and then F. So this is kind of a weird order that I just did that. I started with the first derivative, then second derivative. If you go from the bottom up, first derivative, second derivative, then F. Everyone with me? Okay, I'm going to look at this row right now, okay? Just so you know, that's what I'm looking at now. Go back to the number line that we had from the first derivative. And what were the arrows on that first derivative? They were all down everywhere, right? So what I'd like for you to do is draw arrows down, down, in each of the boxes of your table, down, down, down. Now, go to your second derivative number line and tell me what we had. It was down. Okay, so where was it down? From starting at the left side, it was down to the left of which number? -3, right? So it was down like this. Then it was up between -3 and 0. Then it was down. And then it was up. Do we agree with this? Okay. Now, this is the part that takes a little bit of thinking. The top row is going to be a frown or a smile, but not the entire frown, not the entire smile. It's like you have to cut the frown or smile right in half. Now think about this. I'm going to look right now at this one right here. Just look in here. What is the only way you can be a frown but be decreasing at the same time? Which side of the frown are you on? The right side of the frown, right? If I move from left to right, I'm going down, but at the same time I'm frowning. Agreed? Do you see how that couldn't be the left side of the frown? Because then you'd be going up. Now go to the next column. What's the only way to be going down a smile? The left side. So it looks like this. Then what's the only way to be going down a frown? Right again. And the only way to be going down a smile? Left side. See how that works? Now, a lot of textbooks, I've never seen a textbook do it this way. A lot of textbooks use what's called a sign chart. And they use like positives and negatives and things like that. And I remember when I was like, what? And so this is the way it made most sense to me. This is the way I'm presenting it to you. We basically are putting together the information about the first and second derivative to come up with a basic idea of what the function looks like. With me? Okay, now we are done with part 8. Now we're going to go to part 9. This is the very end of the problem. What I'm going to do is starting right below my table, I'm going to draw my x and y axis for my picture. And notice how I'm kind of just transposing that number line, -3, 0, 3, just down. Y'all see that? I'm lining everything up. Yeah? Or no? Okay. It's all lined up and even. Now what I'd like for us to do is go back to the very beginning of the problem and start going through our information again. We know the domain of the function was -infinity to -3, then -3 to 3, then 3 to infinity, right? So we know where we should have a graph. Where's the x and y intercepts? No, the x and y intercepts. 0, 0, right? So it's time for me to start drawing my function. I'm actually going to draw this dot at the origin. That black dot lives on my function. Okay? Check for symmetry was step 3. We skipped it. Step 4 was find asymptotes. What did we find for asymptotes? Negative 3 and 3 were vertical asymptotes, right? So I'm going to draw them as vertical dotted lines. They are not part of my graph, right? They are just these barriers that force my function to go up or down when I get to them, right? I can't cross vertical asymptotes. I got to go up or down when I get to those, when I draw my function. What about horizontal asymptotes? Where did we say we went towards the ends? Remember when we took that limit? It went to 0, didn't it? So I'm going to draw on the right side a dotted red line going out the x-axis. Same thing with the left side. Next thing. I've got to figure out where I have any other information about this graph. Right now, this is all I've got. I know that over here in this region, right? Over here, I know my graph must look like this little side of this frown, right? And I know in this region here, my graph's got to look like that part of the smile. And I know that in this region here, it's got to look like that part of the frown, right? You get it? What could help guide me to draw the rest of it is by having just one point in each of those regions and plotting them so I know where the function is. So what I'm going to do, I'm just going to leave those colors up there. I'm just going to pick a point, any point I want over here, any point I want in here, any point I want here, any point I want here, and I'm going to plug those points into the original function. So let's try negative 4. Is that a good one? Put negative 4 into the original function. What do you get? Negative 4 over 4 squared is 16, so 7. It's a negative number, isn't it? Negative 4 sevenths. So you could get that as a decimal. It's a little, a little less than a half or a little more than a half? I'm labeling my y-axis negative 1 there. Over here, it would be somewhere in this neighborhood. I'm going to put it in black. It would be somewhere around here, right? That's close enough? Now plug in negative 1. What would you get if you plug in negative 1? Negative 1 over negative 8, right? Which would be 1/8. So over here at negative 1, wouldn't I be up just a little bit like this? What happens if you plug 1 into the function? Negative 1/8, so now you're down here. And what would happen if you plug in 4? Positive 4 sevenths, right? So you'd be here. All right, we're ready. Let's draw it. So I've got my table above this, right? What I know is that at this black dot, I've got to go towards this asymptote, and I've got to go down like this, right? That's basically it, but I'm going to draw it a little better than that. That's kind of crappy. I know that the entire time I draw it, it must look like the right side of a frown. Does that look like the right side of a frown, pretty much? What about from the origin, out to the left, out this way, right? I've got to look like the left side of a smile. So I'm going to connect those dots. It's got to go like this and then go through that damn it. Go through that, and then go up. And the vertical asymptote forces it up, right? The right side, coming out the right side, must look like the right side of a frown, so it looks like this. And then when I go over to the dot on in the fourth little region over there, or third region on the right, it's got to look like the left side of a smile, so it's got to go up, and then it's got to come down towards the, yes. That's a good question. Horizontal asymptotes do not block your function. All they do is tell you what happens at the ends. A lot of times I'll see tutors do this, like in tutoring lab. When they get a horizontal asymptote, they'll draw a dotted line all the way across, and that makes students think you can't cross them. Horizontals you can cross. Verticals you cannot cross. All right? So it's fine. Whatever's happening in the middle of the function doesn't matter. It's only at the edges you have to go towards your horizontal. So that's a lot of work, right? I mean, that is a friggin' tremendous amount of work for that rational function. But the idea is what I want you to understand, that you can take pretty much any function, and as long as you can do this process, you can sketch it. Oh my gosh, we're out of time. Well, yes. I know, sorry to disappoint you, Frank. Our homework's going to change a little bit here, so let me run back up to this. Was it that bad, Frank? I can handle honesty. Is it the material, or is just this class? Okay. This is the only thing you need to work on for next time. And as you probably are aware of now, that's a lot of frickin' work right there. Because 4.4 is what we just did, that problem we just did right now. That's 4 problems like that. And the derivatives on those are nightmares. So you should try and tackle, if I were to be sitting back and saying, what am I going to focus the next 48 hours on for homework? Like, where would I gain the most putting my energy? It would be going straight to 4.4 and doing 11, 19, 22, and 23, because those incorporate the skills from 4.3, right? You have to do the stuff from 4.3 to do those problems in 4.4. So that's where I would start. For next time, the watching of the videos, I'd like for you to, of course, watch 4.6, watch 4.7, but include with this 4.5 because I didn't get a chance to cover 4.5. Adios. If you have a question about your test or anything like that, feel free to... Oh,